Next, we want to talk about the natural logarithms, section 7.2. What's a natural logarithm? We are going to define the natural logarithm in terms of integral. Integral from 1 to x1 over t dt, as long as, of course, x is a positive value, this is defined as ln x. So actually ln x is finding the area underneath the curve 1 over t. You remember 1 over t graph, right? 1 over t is the butterfly graph. Butterfly, you remember that. Okay, so starting from 1, you're going to go to x, and this is going to give you ln x. The area underneath that curve is the natural log. It's defined as natural log. That's the definition. You will see that this is the butterfly, part of the butterfly function 1 over x. And what is ln x? This x has to be positive, by the way. X could be less than 1, that's fine. Ln x will be from 1 to x1 over t dt. Okay, since 1 is bigger than x, we just take the reciprocal of this negative x to 1 over t dt. Okay, so it's gonna give the negative of this area. Yes, okay, negative of this area, that's fine. It has a negative value, by the way, ln x when x is less than 1 but bigger than 0. That's okay. And it's gonna give a positive value if x is greater than 1. ln x is this area, 1 to x1 over t dt, and it's gonna give the blue area, no problem. And how would you find the inverse of this? So what you could do is you can draw this y is equal to x and take the mirror image. Okay, the mirror image is gonna take this piece down here. All right, and this y is equal to x is gonna go through here, and your mirror image at this point, it's gonna say take this part down here, which is the mirror image, and you get this picture, and this is the graph of ln x. Okay, what is ln 1? ln 1 at x is equal to 1, it is the integral 1 to 1 over t dt, but we know integral a to a f of x is 0, so ln 1 is 0, we know that, right? And it's this point. ln 1 is this point. All right. What else I can tell you? These are just values that are defined. For example, for x is equal to 0, it is undefined because x values has to be greater than 0. Okay, so this table is nice because it's gonna tell you, for example, at x is equal to 1, ln 1 is 0. When x is less than 1 and bigger than 0, it takes negative values. When x is bigger than 1, it takes positive values. However, when x is equal to 0, it is undefined. This is a nice table in that sense. And we have a number e. Everybody knows number e. Number e is between 2 and 3. It's a transcendental number. Okay, it's what is natural log of e? It is integral from 1 to e1 over t dt, and this is gonna be 1. When you calculate this integral, it's gonna be 1. Okay, and the derivative of natural log of u is going to be 1 over u du dx. So what you do here is you use the chain rule. Actually, the derivative of the natural log is 1 over the inside function. The inside function is u, so 1 over the inside function times, because of the chain rule, don't forget to take the derivative of u inside natural log because u is a function of x, so times du dx. So we have a chain rule here, and this is going to be true for u greater than 0 because natural log is defined for positive values, right? Okay, what are the algebraic properties of the natural log? We have the product rule, we have the quotient rule, reciprocal rule, power rule. Let's see them. So we take the b a positive, non-negative positive number, and x is a positive number because we have to be careful. And natural log of b times x is natural log of b plus natural log of x. You can remember these from your high school. Natural log of b over x is natural log of b minus natural log of x. Natural log of 1 over x is natural log of 1 minus natural log of x, but natural log of 1 is 0, so it's negative ln x. Natural log of x to the r, this is the power rule. You take the power to the front of natural log, r times ln x, okay? So you are seeing here, you are seeing ln x and the inverse of ln x here, 1 over x. And now this is this formula 3 is very important. If you use a differentiable function, then integral 1 over u du is antiderivative of 1 over u is natural log of the absolute value of u plus a constant c. Don't forget to add the constant c because this is indefinite integral. So as long as you use a differentiable function and never 0, then we have this. Let's look at these integrals. Integral of tangent u is natural log of absolute value of secant u, and integral of cotangent u is natural log of absolute value of sine u, of course plus c for both. Integral of secant u du is natural log of absolute value of secant u plus tangent u plus c. Integral of cosecant u du is equal to negative ln absolute value of cosecant u plus cotangent u plus c. Okay.